So what this is going to go over is probably the most important little calculation. So we've gone over a lot of the basics of equilibrium. We know what it is. We know that the K value means something. We know that equilibrium can shift when there's stress is added to it. So this right here, these equilibrium calculations, it's all based around a rice table. Okay. Rice stands for something. It's not the food rice. Okay. But it's a rice table. And what this rice table is going to do is it's going to organize information or data or, kind of your ingredients. It takes into account the mole ratio, and it has you solve for your equilibrium constant. Or you can use an equilibrium constant from a book, and you can solve for what should the concentration be at the end of a reaction after it reaches equilibrium, okay? So a rice table is just a really neat way to organize your information. We're going to be using it pretty heavily. I shouldn't say pretty heavily, but we use it in acids and bases, which is the next unit as well. So it's good to learn the basic one with this, because in acids and bases, you're going to have 2 extra steps to it. Okay, so make sure you are paying attention with this one, okay? All right, so for our example number 1, you guys can read it on your own paper. It just says that consider the following equation. By the way, what color is FeSCN2? Does this reaction look familiar to you? You did it yesterday. Station B. Yeah, it's the orange-red color. It's the blood-looking color, okay? All right, so this is your reaction from yesterday, basically. All right, and it says that we have 2 molar iron, 2 molar thiocyanate are mixed in a container. At equilibrium, there is 0.6 of the iron thiocyanate. Calculate your equilibrium constant. So in the end, we are looking for who? What is our final goal in this question? Calculate, yeah, so we're going to calculate K, right? So what do you think I'm going to have you write before we even start moving through this problem? The formula, yeah, the K expression, right? So we're going to, up here, we're going to write K is equal to, who goes on top? The products, which is iron thiocyanate. Does it have an exponent? The products? No. Okay. And then the reactants, we have iron. If you notice, iron has a little charge on it. The reason it does, I chose not to show you guys the net ionics yet, but net ionics take out spectator ions, which was one of your questions in the solubility rules lab. Okay. So you have to put the charge. If I give you a charge, it means that I wrote you a net ionic equation, which is the main show of your reaction. So you only write who's actually doing something. And these are the 2 compounds that are coming together and actually making something, okay? So, so you have to write the charge, because technically that iron could be connected to chloride, like our iron 2 chloride that we had yesterday, okay? So you have to show that with the charge. If you didn't understand anything I just said, just please put your charges. Got it? Yes? Cool, sweet, awesome. I saw a lot of blank faces. All right, SCN, and that one gets, we have a minus sign on the inside, but what goes on the outside? A 2, good. All right, cool. So we have our equilibrium expression ready to go. So eventually we're gonna have to plug into that, okay? All right, so along the side, I want you to write the word rice. Okay, so you're going to go R-I-C-E. And each of these are going to stand for something. Okay, so the R up top stands for, there you go, reaction. Okay. So when we're writing the reaction, it just means that you're writing the balanced equation. So if you have the balanced equation already written for you, you usually don't have to do this step. But we don't. It's way up there. So we're going to rewrite it real quick. Give yourself a little bit of space for it. This could also be a place where if you notice that you have a solid or a liquid, you don't have to necessarily put them in to the rice table, or you get to put a big X over them and it makes your rice table smaller and it's great, okay? But for this, they're all aqueous, so they're all included. All right, the I. I stands for initial. So if you remember, what did I tell you? Oh, I cannot spell. That's great. Let's try that again. All right. What did I tell you about the equilibrium expression? What values actually go into that? What you're mixing together, or what it all looks like at the very, very end? So our equilibrium values are what go into the expression. So the initial stuff is what we get from our problem. This is saying, hey, I have a beaker full of this, I have a beaker full of this, that's what I'm going to mix together. But these are the ingredients. So we're going to put those concentrations into the table. Okay? Please notice they're both in molarity. They are in concentration. If I give it to you in moles, you got to solve for molarity. That's the ice table only works with molarity. Okay? If you do it in moles, it's called a BCA table, but we're going to do that later. All right. So we have that. Okay, so what do I put here? Initially, how much of that do I have? Do I have any? That says at equilibrium. So this one is not an initial value, is it? That one's after the whole thing happened, right? So initially, I don't have anything. You put 0. Right? You guys remember in your straw lab, you had the reactants went like this, the products went like this, right? Products started at 0. Okay? So we start our products at 0. This is showing that my reactants are starting at 2. You see that? Okay. So the next line is change. All right, so this is where algebra is going to come into play. Okay? And this is going to be the part that takes into account your mole ratio. Without having to do stoichiometry and all that stuff, this takes care of it. So what we do, what did we say the reactants do? Do they decrease as the reaction goes, or are they increasing as the reaction goes? The reactants. Are they going to decrease? Yeah, they decrease. So we're going to go minus x. X just represents the change. For this one, I'm going to put minus 2x. Why am I putting minus 2x? Yeah, there's a coefficient. Okay, because of that coefficient, we got to put the 2 there. So if there's a coefficient, you got to add that in there. All right. But our products, what do we know our products are doing? They're not decreasing, they're increasing. So we're going to go plus x. There's no coefficient here, so we're just going to leave it plus x. If you want to put in the ones to make it more, make more sense to you, you can do that. Okay. All right. Cool. So that's the change line. You got to use x. All right. And then finally, this bottom part, I always like to put a line across like this. Okay. But this bottom part is your equilibrium values. Okay. And you basically just made an expression going this direction. Okay. So what we're going to do is we're going to write the expressions. As you get better at it, you don't have to write this part. You can just solve for it, okay? So 2.0 minus x is going to be equal to this value, right? I'm just taking straight from my table. This one is going to be 2.0 minus 2x. This one is going to be 0 plus x. And then, back up in the problem, we had this little piece of information. That 0.60 is at equilibrium. So that means it goes in this part of the table. So we're going to put the 0.6 right here, because it was at equilibrium. So according to this expression, what does x equal? Yeah, 0.60. And what do you think we're going to do with that? We're going to plug it into, yeah, both of these to figure out what are my equilibrium concentrations here. Okay? So 2 minus 0.6. You can do that one in your head. What is it? 1.4. What's 2x? So what's 2 times 0.6? 1.2. So what's 2 minus 1.2? 0.8. So I have 1.4, 0.8, 0.6. What are we going to do with those values? Yeah, we're going to put them back into our expression to solve for k, our ultimate goal. So you're going to have 0.6 divided by, and you're going to have 1.4 times that 0.8, but we got to square that guy. All right, so when you're plugging into your calculator, you might put parentheses around the bottom if you're going to multiply them all together. Okay, and, ooh, just kidding. Type it in. Should be getting, if I remember correctly, this. But check to make sure that's what you're getting. Yeah? Okay. So if it's 0.67, who is favored, my reactants or my products? Reactants. Reactants. It's less than 1. Yep. So reactant favored. All right, cool. So are there any questions on this so far? Okay, so what I'd like you guys to do is turn your page. Oh. And tomorrow we can hit a couple more of the more difficult ones, but for now I want to see you guys use what you just learned, okay? If you missed everything I just said, you have this example over here on this side. Okay, and you can look at the process, all right? And it kind of walks you through it. But what I want you guys to do is try a couple of these over here, okay? So if you notice, the ICE table is already set up for you, okay? It just goes R-I-C-E, all right? So it already has that. I know this says ending, but equilibrium, same thing, okay. Huh? At least, I want you to pick a couple of them. Do number 1 for sure. That one I got the key memorized. But what should be your first goal? You should fill out the change line first, right? And then you should solve for x. Once you solve for x, now you can fill out the rest of these guys, okay? Okay, I do want you to tell me what the k value is for each of them as well. All right, got it? Sweet.